Today we are going to discuss about gantry girders. Gantry girders are used in mill and heavy industrial buildings such as factories and workshops, where gantry girders are supported by columns and carrying cranes. These are handled basically to transport the goods and equipments from one place to another place in the workshop. And gantry girders are a typical example for laterally unsupported beam in industrial buildings. Also, gantry girder undergoes both bending moment under both the direction. One is vertically, another is laterally. So, biaxial bending moment has to be also checked for design of gantry girder. Therefore, when we will be going to design a gantry girder, we need to consider two things. One is the gantry girder is a laterally unsupported beam. So, we have to design the gantry girder considering the lateral torsional buckling effect, and also we have to consider the biaxial bending. That means that interaction formula has to be also checked. That means that md by mdz plus md by mdy less than or equal to 1, that interaction formula for biaxial bending moment has to check. So, these are the two aspects in the, and also in gantry girder we will see the loads are moving from one place to another place. Therefore, we need to know little about influence line diagram. That means where we have to see the position of load in which the maximum bending moment is going to occur and the maximum shear force is going to occur. So, as the wheel is moving from one place to another place, we will place the wheel in such a way so that we can achieve the maximum shear force and also we can achieve the maximum bending moment, and against that maximum shear force and bending moment we will design the gantry girder. Also, here another thing we will see that because of this load, certain impact load will come into picture. So, due to impact some additional load has to be added in the load calculation. That also in code it has been recommended certain percentage of addition, that we will learn today. Also, the lateral load, certain percentage of load will be acting as a lateral load, for which lateral bending moment and lateral shear force will be produced, and because of that also we have to check the lateral bending strength and shear strength, so that it is not going to fail under this lateral load, right. And in overhead travelling crane runway system, it consists few components like crane. Then this crane is comprising the crane girder, crab or trolley, hoist power transmitting device, and a cab which houses the control and operators, and also the crane rails and their attachment, also the gantry girder and column with bracket supporting gantry girder. So, the general arrangement of gantry girder we can see, so that we will be able to understand how to design it and how it looks. The general arrangement of the gantry girder. Say gantry girder is placed on the column either with the support of a bracket or with the step column. Say for example, if we use the step column, so this is an I section with step column. After certain height, the section has been stepped. Say for example, this, then it has some, we use some on the top of the step column, we use some packing plate. Then we use, generally gantry girder are consisting of I section in general, and at the top flange we provide, along with I section we provide another channel section, right. So, this is I section, and top of that another channel section also provide to take the heavy load which are coming from the crane girder, and this is basically gantry girder. And top of the gantry girder, it will be connected with a member which will carry the crane girder. So, crane wheel will be produced here, say for example, here the crane wheel will be there, from which the crane girder will be connected, right. So, this is the crane girder from which the trolley are kept. Say this is called crab, a trolley from which the load means the instrument are shifted from one place to another place, right. And this is called crane girder. And this is diaphragm which keep the I section, the gantry girder, in position throughout its length. So, this is how one can keep the gantry girder in place. This is called diaphragm. Right, and this is the crane wheel. This is tape column. So, this is the we can say this is the front view of the system, where the gantry girder is placed on a step column. And if we see the top view, we can see that two means in between gantry girder two columns are placed. So, these are the step column. Say another column is placed here, between which the gantry girders are placed on the column. This is one column, this is another column, and this is the gantry girder. So, gantry girder are supported between two columns, and this gantry girder is carrying a crane girder, in which a crab is placed. So, this is crab. This is crane girder. Right. So, this is the top view of the general arrangement. Right. This is column. Okay. So, general arrangement of a gantry girder can be shown like this, and here we can see that gantry girder is supported on two columns here and here, and then throughout this gantry girder the crane is moving, and this crane is moving in this direction or in this direction, right. another is this crab can move in this direction, crab can move, right. So, what we can see that when we are going to calculate the maximum bending moment and shear force on the gantry girder, we have to see what is the maximum load effect. So, maximum load effect will be when it is in the closest position to the gantry girder. So, the crab position should be at the closest to the gantry girder, we have to consider, then the maximum effect we can find, and then again once the crab position is located, depending on the clearance from gantry girder to the this crab wheel location, then we can again find that the crane can move in this way, right. So, the crane can, one wheel can support on this and some other wheel can support on this to get maximum shear force, and also to get maximum bending moment we have to support, means we have to consider the crane girder somewhere mid span of the girder, so that we can get maximum moment. So, this is how we have to find out. So, before finding the maximum bending moment and shear force, we have to see whatever load are going to be acting on the girder. So, load will be like this. One is the vertical loads which are coming from the crane, because crane will be carrying certain instruments, certain heavy machines. So, that load we have to consider, for which the bending moment and shear force on the gantry girder will be developed. Then impact load from the crane. So, because of the load in the crane, certain impact load will come, because we are transporting certain heavy items from one place to another place. So, during operation certain impact will come into picture. So, we have to find out what is the percentage of impact load, means percentage of load will be increased for the impact, and we have to add that. Another load is the longitudinal horizontal force along the crane rail. Along the crane rail certain longitudinal horizontal force will come. So, that has to be taken care. Next is the lateral thrust across the crane rail. So, certain thrust will be generated. So, that lateral thrust also has to be calculated. So, again as I told earlier that when we are going to calculate these forces, we need to position the crane, means the trolley, in such a way that it gives maximum design force in the girder. So, we will design the girder on the maximum effect. So, that we have to keep in mind. So, for that we will place the load accordingly. Now, the impact load. So, the codal provision says that for vertical load, when it is an electric overhead crane, then 25% of the maximum static wheel load will be added. So, additional load, how much percentage will be added, that has been given here. So, in case of electric overhead crane, 25% of the maximum static load will be added, whereas for hand operated cranes it will be 10% of the maximum static load, right. And this is vertical load. For horizontal forces transverse to rail, for electric overhead cranes it will be 10% of the weight of crab and the weight of lifted on the crane, right. And for hand operated cranes it will be 5% of the weight of crab and the weight lifted on the crane. So, this is how we have to means we have to calculate the additional load due to impact. Then horizontal forces along rail, that is 5% of the static wheel load, that has to be considered. So, when we are going to design a gantry girder, we first need to calculate the additional load which are coming due to impact, and that has to be added with the developed load, and then we have to go for maximum effect for those loads, and then we have to go for design. So, lateral load. As the crane moves with the load, we know the lateral load will be developed due to application of brakes. or sudden acceleration of trolley. So, because of application of brake or sudden acceleration of trolley, certain amount of load will be developed, which is called lateral load, right. And what is the percentage of lateral load? That is told in IS 875 that 10% of the weight for EOT cranes as horizontal loads, right, where W is the total weight including lifted weight and the trolley weight. So, if the total weight which includes lifted weight and trolley weight is W, then 10% of that W will be the lateral load, which is recommended by IS 875. Then longitudinal load. Longitudinal load, that when the crane moves longitudinally, loads parallel to the rails are caused due to braking or acceleration and swing, means starting of the crane. This load is called longitudinal load and is transferred to the rail level, is transferred at the rail level, and that is 5% of the wheel load. So, longitudinal load per wheel will be considered as 5% of the wheel load. So, this is how one can calculate the magnitude of the lateral load and longitudinal load, and that can be calculated if we know the wheel load and the lifted load and the other self weight, etc. So, on the basis of that we can find out the lateral load and longitudinal load, and then again we can find out the impact load, right. Now, permissible deflection. So, that has been given in the IS 800 2007. In table 6 the permissible deflection has been defined there, where which has been reproduced here, where for different category the maximum deflection limit is cited, such as the when the manually operated cranes are operated and for similar loads, the maximum deflection will be considered as L by 500, where L is the span of the girder, right. Similarly, for electric overhead trains, travelling cranes, that means EOT, which we used to say EOT, electric overhead travelling cranes operate, so up to 50 ton, it is considered as L by 750, and over 50 ton this maximum deflection will be L by 1000. So, when electric overhead travelling cranes operate over 50 ton, then the maximum deflection will be span by 1000, and for other moving loads such as charging cars, etc., it will be the permissible limit is L by 600. And for lateral deflection, relative between rails can be considered as 10 mm or L by 400, whichever is less. So, the permissible deflection are given in table 6, from which we can take the value, and maximum deflection which are coming we can calculate, and we can check whether from serviceability point of view this the design is okay or not. Now, coming to maximum load effect. So, maximum load effect means it depends on the position of the crane hook. So, if this is the crane length, if we consider if this is the crane length, then the trolley can move from this direction to this direction, right, and maximum effect on the girder has gone in this direction, right. So, maximum effect on the girder will be when this trolley load will be at the closest distance from the support, right, and that is possible when it is coming towards support, and that can come up to minimum approach of the crane hook. That means, we know the crane has having wheel. So, wheel cannot come up to this, it has certain approach, minimum approach. So, excluding this minimum approach, we can keep one wheel here and another wheel here. So, its CG will be at the middle of this where the CG of the wheel and support are defined as L1. So, if L1 is the minimum approach of crane hook, that means distance between CG of gantry girder and trolley, then we can find out the maximum effect, right. So, maximum effect, this means R, the reaction force, that will be the maximum when it will be, this will be when if W is the unit length, means unit weight per length, sorry, weight per unit length, then R A due to this W is W L C by 2, where L C is the length of crane, right, span of crane girder. So, one will be W L C by 2, because the uniformly distributed load is W. So, W L C by 2. Another is, if I take moment through this point, then I can see R A into L C is equal to W T into L C minus L 1. So, from that I can find out R A is equal to W T into L C minus L 1 by L C. So, total R A due to crane load and the wheel load will be W L C by 2 plus W T into L C minus L 1 by L C. So, from this equation also we can see that maximum R A can be achieved when L 1 is least, right. So, we will keep the minimum L 1, minimum distance, so that the maximum load on the gantry girder can be achieved, for which we have to design, because for worst condition we will be designing. So, once the load is found, means the maximum R A is found, then we can find out the maximum effect on the gantry girder. Maximum effect means, as you see, the if we consider this is the crane and this is the gantry girder, then crane when it is moving towards this, then we can find out if this is simply supported gantry girder, then we can find out the maximum bending moment will be more or less towards mid span, but it will not be exactly at the mid span. So, that can be found. If we see if this L is the length of the gantry girder, then mid span length will be L by 2, right. Now, if we put the wheel position in such that the CG of the wheel and another wheel is the means mid distance from the center of the span, then it will be the maximum. That means, if this is the center of the span and if CG of the wheel is this, then equidistance from this, if we keep the wheel in such a way, then the maximum bending moment can be achieved. That means, when one wheel is positioned at A by 4 distance from L, means from center to any direction, then the maximum bending moment is achieved. That you can exercise and you can see where the maximum bending moment can be achieved. That means, we can find out an equation in terms of x for the calculation of moment, and then we can find out where the maximum moment is developed. So, after calculation we can see this is the position where maximum moment can be developed. So, again shear, maximum shear also can be developed. That is possible if one of the wheel is positioned at the support of the gantry girder, right. So, maximum reaction we are getting for this as R A by 2 and another is proportionately, right. Means if the distance between two wheel is A, then accordingly I can find out reaction at C. So, reaction at C will be R A by 2, that means R C will be R A by 2 plus R A by 2 into L minus A by L, right, R A by 2 into L minus A by L, right. So, this will be the reaction at C. So, maximum shear on gantry girder can be calculated from this when one of the wheel is positioned at the support, right. Now, fatigue effects. So, gantry girders cause moving loads which cause fatigue, and fatigue effects for light and medium duty cranes need not be checked if normal and shear stress range is following this, that is F is less than or equal to 27 by gamma F t, right, where gamma F t is a partial safety factor for strength, and this gamma F t value can be obtained from table 25 of IS 800/2007. So, if the shear stress range is less than 27 by gamma F t, then we do not need to check, or if the actual number of stress cycle NSC is less than 5 into 10 to the 6 into 27 gamma F t by gamma m into F, where F we know and F is the actual fatigue stress range and gamma m is the partial safety factor, which is 1.1. So, either of these we need to know, and for these cases we do not need to check. However, for heavy duty crane the gantry girder must be checked for fatigue. So, unless heavy duty cranes are there, we do not need to check, and in case of heavy duty crane we have to check the gantry girder for fatigue also. Then normal stress range. Normal stress range, the design normal stress F f can be found from this formula, that is F f n square root of cube root of 5 into 10 to the 6 by N S C, when N S C is less than 5 into 10 to the 6. So, for this F f can be calculated from this expression, and F f can be calculated from this expression, that is F f n into 5th root of 5 into 10 to the 6 by N S C, when N S C is greater than 5 into 10 to the 6 and less than 10 to the 8, right. So, the design normal fatigue stress range can be found from this expression F f for different value of N S C, right, and shear stress range can be found from this formula, that is tau f is equal to tau f n 5th root of 5 into 10 to the 6 by N S C, where tau f is the shear fatigue stress range. Okay. So, this is what for fatigue check we need to carry out, right. So, in gantry girder what we could see that gantry girder is basically an laterally unsupported beam, and which need to design both for vertical load and lateral load, right. And we have seen here that certain percentage of load will be considered as lateral load, and also certain percentage of load will be calculated as impact load. So, we can calculate the impact load, lateral load, and then we can find out the total load vertically and horizontally. Then we need to design due to those vertical load and lateral load, and design will be for two criteria. One is the bending moment due to this vertical load, another is bending moment due to lateral load, and we have to check whether the design bending strength is capable of taking the developed load or not, and we have to check the interaction formula also, as this is a example of biaxial bending. So, for biaxial bending we need to have another check, right. This is what we have to do, and also for calculating the bending moment and shear force we need to know where the maximum development will be happen. Maximum development means maximum shear force and maximum bending moment. what will be the position of wheel, so that we can achieve maximum bending and maximum shear, against which we need to design, because we will design for worst condition, so that under worst loading condition the girder does not fail. So, basically gantry girder is nothing but a laterally unsupported beam, which can be designed if we know the loading conditions, means loadings, and if we know the different type of loadings how to calculate, right. So, with this we will go to the example, means how to calculate the loadings and how to make a design of gantry girder. We will try through one example in next class. Thank you.